Hey guys, it's Jake, and thanks for tuning in to the fifth of our mini-series of tutorials to introduce you guys to 3EO4. As with all the previous little lessons that we've had, don't feel obligated to sit through this entire thing, and if you don't think that what we're going to cover today is going to be useful, then you don't have to watch it. This is here for your benefit. So what we're going to look at today is a little more logic. So we're looking at some while loops in complementary, or in combination with, I suppose, the for loops that we took a look at in tutorial 3. We're also going to take a look at some if statements, and if we have time, I'm going to show you guys what breakpoints are and how they're a little bit useful for troubleshooting and for other functions as well. So with that, let's get started. You can see I've already got a file opened up here. I've called it T5, and I've inserted my 3 famous lines of code that we always want to have. So that is already there. So I'm just going to throw in a pre-made comment that I have right here. And I want to just talk briefly about while loops. So while loops are useful for performing certain calculation for a defined range of conditions or for performing some sort of task indefinitely until a condition is met. So most of the time a while loop or a for loop can both be used. They can be used interchangeably, but in some situations it makes more logical sense to go with the while loop over the for loop or the for loop over the while loop. So what we're going to look at today is a bunch of different ways to use while loops while also incorporating a little bit of logic. So I've got a very basic example. So these are going to be simple examples. We're going to get towards something a little more useful and a little more numerical methods-y toward the very end of this tutorial. But to begin with, we're just going to make a simple while loop that will count from 1 to 100. So the first thing I'm going to do here is define an index. So I'm going to call it I for index, and we'll call it, an index that I'm going to keep track of. And then what I'm going to do is I'm going to make a variable called first target. So I'm going to make that target 100, and I'm going to say, okay, I'm going to count from 1 to 100, so that's going to be my target. Now I could just as easily use the number like 100 inside the loop, but it's good practice to usually make variables for this sort of thing, so that if you wanted to change your target and say have it count to 500 for some reason later on, instead of going and changing every instance of 100 with 500, you only need to change this one variable, which will be called in the loops from this point on, and save yourself a little bit of time. So with that, let's go ahead and get right into the while loop. So we're going to start with while and then a space, and then we're going to have some sort of condition that goes in right here, and then down here I'm going to type in end. And you can see in between it's got a tabbed in automatically, which is going to show us that we're inside the loop. You don't have to have things tabbed in to be inside a loop. I know with certain things like Fortran and even Python you need to have things tabbed in, but that's not the case in MATLAB. So just a heads up there. So I'm going to say I'm going to have some sort of logical condition here. So while I, which is our little index that we're keeping track of, is strictly less than 100. So I want to do this as long as I is less than 100. And I'm sorry, I don't need a semicolon there. And then by 100, instead of that, I'm going to write in first target. So I could write 100, I just forgot there, but instead I'm going to use this new variable that I've made called first target. And then inside the loop I'm going to have a couple of commands. So I want to have one maybe that says the MATLAB count currently sits at, and then I'm going to put in my placeholder, the %g, and then I'm going to put in a new line, and I'm going to have it print out I. So every time we go through this loop, it's going to spit out the MATLAB count currently sits at 1, then 2, 3, 4, 5, etc., etc. And then I'm going to throw in a quick little pause here. Pause is a very simple command. Either you can put in pause by itself, and what it will do is it'll pause the running program until you hit any key in the command window, and then it will go ahead and continue. But if you put a little number here in brackets, it'll automatically pause that many seconds. So in this case, I just wanted to pause 0.05 seconds. The reason for that is that I wanted to display the output like in a row here. If I didn't do that, it would just be like instantaneous. It would have all those lines up because it's a very fast calculation. So I'm just going to have it slow down a bit so we can see it going one at a time. And then of course I'm just going to go I equals I plus 1. And what that's going to go ahead and do is increase our counter. So it's going to increase our counter, say to 2, exit the loop, and it's going to come back up here to the while loop, and it's going to check this condition. And now it's going to say I is equal to 2, it's less than or equal to, or sorry, strictly less than 100, so then we're okay. And then we're going to go ahead and continue to calculate that through. And then at the end of the loop, I'm just going to print out a confirmation that we have actually finished our calculation. So and then while loop. Note that I'm using double quotes here, which are just counted as a string. If I used a single quote, it would think that it's the end of what I'm trying to type. So I got to use the double quotation mark there. And it has finished counting to the first target. And then I'm going to add a couple of new lines here, 2 new lines, and that's going to be the end of that. And then I'm just going to put in a pause. Pause. So now I'm going to go ahead and run this. So let's see what happens. So what should happen is the screen will print out the MATLAB count currently sits at, and it will start at 100 and go, or at 1 rather, and go all the way up to 100. So I'm going to run it. As you can see, it's just printing out those numbers, and then it's just going to go ahead and do that. Alright, so it says the while loop has finished counting to the first target, and then it gives me a couple of free lines there. Now it's currently paused, so you see pause down here, press any key. So if I press the space bar, it will finish the code, which is nothing at this point, and then give me this double hatched bracket here, which means I'm ready to go into the next command line. So if I type in I, it will return that number 100. So notice that I used the strictly less than first target here, because I have I incrementing inside, and then when I is equal to 99, I'm going to end up getting up to 100 through this last thing here. But it's not going to print out that I'm at 100, because it's only going to get up to 99 up here, and then print out 99. Then it's going to get to 100 when it calculates this, and then this loop is going to be not satisfied, so it's going to end up not printing that last line out. Now if I had put this line in front of this line, then it would get to 100, but then the first number that it counts up here would actually be equal to 2. So just where you place things ends up making a difference, just so you know. So that's just a very basic while loop that's going to count from 1 to 100. So now there are lots of different ways that I could have written this loop. So what I'm going to do right now is I'm going to write this kind of the same thing, but in a different way, to give you guys a different idea and to introduce what a break is in a loop. Not to be confused with a break point, but what I'm going to do is put in a break to exit a loop. So let's say we're going to keep going from 100. We're going to make it count up to 200. So I'm going to put in a new variable here called second target, and it's going to be equal to 200. And then here's what I'm going to do. I'm going to make a new while loop, and I'm going to have a condition there. Let's not use ampersands. Let's use these. I'm going to go down here and end. And what I want to do is, instead of having the logic be up here, I'm going to ask it to do a loop indefinitely. So an indefinite loop, one way to do it is to type in a 1 in brackets, and that just means while 1 is 1, basically, I want you to do this, which means forever. So just do this forever. And then what I'm going to say is take this line again. It's going to tell me what the MATLAB count sits at. So it currently sits at, and then in this case I is still 100, because it's still 100 from when it got counted up to here. So it's going to start by spitting out that it sits at 100, and then I'm going to introduce these same 2 lines again and just have it continuously count up. So now what happens if I go ahead and run this? Well, as you might imagine, it's going to just continue forever. So here we're going to go through our first loop. We're going to get up to 100, and then it's going to pause. So it's paused. So I press spacebar, and now it's just going to keep counting. And now what's going to happen now is, because I've got an infinite loop going here, and I've got no logic to try to get out of it, it's just going to continue to go until infinity, which of course we don't want. So one useful command that I like to make sure that everybody knows is that if you get stuck in an infinite loop, or you get stuck in a calculation that's taking longer than you think it should, then what you can do is go to the command window and press Control-C, and it will terminate by the user, and it'll tell you what line you're at, and that doesn't really matter. So obviously I knew I was inside this loop because it just keeps going. But if you get stuck calculating something, just go ahead and hit Control-C, and that'll exit for you, and you can go back to doing your work. So clearly this infinite loop is not going to work out too well for me, so I need to have some way of getting out of it. So I'm going to put in an if statement. So I'm going to check to see if I is greater than or equal to this second target. So in other words, 200. If I is greater than or equal to 200 in this case, I want it to print out a new line, and I want it to say the MATLAB count has reached. And then I'm going to throw in a placeholder here and a new line, and that the placeholder is going to be I. So in other words, it's going to print out the MATLAB count has reached 200 because second target is equal to 200. If I change it to 300, then it would print out 300. And then I'm going to have a new command, and it's going to be called break. And now that break line, throw in a semicolon here, is going to do something specific. And now with every if statement, just the same with any loop, you require an end. So I'm going to go ahead and go an end, and then you can see that it automatically lines up with the if. So that is the end of my if statement. Now I can also put in an else, do a typical if-else condition, but in this case I only want this to execute if this condition is met. Otherwise I don't really care what it does, and I'll obviously have some sort of error if it just continues to go for infinity, so my logic might have been incorrectly input. So what the break does is it looks outwards from the if statement in this case, or from whatever line of code you're in, and it looks for the nearest loop. So it's inside this loop right here, this while loop. And what it will do is it'll exit that loop. So it'll forced exit that loop automatically. So let's try that. Pause. So now if I run this, what's going to happen is we're going to go through our first 100 count. So we're going to get through here. It's going to pause, just like I asked it to. And then we continue. We're going to go for 100, and we're going to get up to 200, and you'll know that this loop exits. MATLAB count has reached 200, and now we're paused again because we reached this line. It broke out of this loop, and now we're paused. So we just press the space bar to finish that up. And so there you go. So that's what a break does. It gets us out of a loop when a certain condition is met. So these two loops, this guy and this guy, end up pretty much doing the exact same thing, except for they count from 1 to 100 and 100 to 200. It doesn't really make a difference. But I just wanted to show you guys that there are multiple ways to get outside of a loop. You don't have to use the logic inside the loop itself, but you can go ahead and do some sort of conditional logic inside. And now that works for for loops as well, very well, as well as a whole bunch of other situations that the break is useful, as well as for troubleshooting, which I'm going to get into in our next example. Sometimes it's useful to put in this kind of logic to avoid doing too many iterations for a certain, say, numerical method. Say you're doing Newton's method, which we'll cover in the class, and you want to identify a root to within 0.001%, but you want to make sure that you don't take more than like 200 iterations to do that, because then it'll take too long, and obviously once you've got that high, something must have gone wrong. So this kind of thing is useful to make sure you don't exceed some sort of maximum number of iterations. So the other thing I'm going to show you is the breakpoint. So what I'm going to do here is I'm going to throw in this breakpoint right here. So by clicking on these lines over here, you can have the code, whenever it reaches that line, it'll pause, it'll stop, you'll get a little green arrow over here, and it'll tell you, okay, I've gone through your code and I'm sitting at this line, what would you like me to do? So if I run this right now, let's comment out this pause just so it does it really quickly. So there you go. I told you if you took out the pause, it would be like instantaneous. So there you go. It went all from 1 to 99 pretty much instantaneously. So it's at this pause right now, so I'll execute that. And then you can see this little K down here, which means that we're at a breakpoint, K for breakpoint. And you can see this little green arrow. It says we're at this line. So I can just do things like check, to see, okay, so I is equal to 101. I can look around, I can look and see what second target is, and this works for vectors as well. And then I have a few options here. I can continue, which will just continue running the code until it reaches the next breakpoint, which, since we're in a loop, it's going to go down here and then come back up and then come back to this again. That's the equivalent to hitting F5. I can also step, so go one line at a time. So if I do this, for example, I can see that, okay, it didn't execute these lines because it knows that I is 101, which is not greater than or equal to 200, so I clearly skipped this line of logic. It's at the end. I take another step, and now it comes back up to this while loop, and then it's going to print out the line over here, and then it's going to pause, and then it's going to do I equals I plus 1, so now it's 102. And now it's going to check this logic again. You can see it's going to skip it a second time. So if I were to continue, I could just keep pressing this continue button, and it will continue to go through the loop and get stuck at this logic. So I'm going to take away that breakpoint, and instead I'm going to put it in here. And now it'll only get in here if this logic is ever met. So if I press continue, it's going to continue doing its own thing. And then once we get to 199, we know that I has gone up to 200, so this logic has been met. So now I know that I'm going to have these two lines right here, so if I step, it'll say it has reached 200, and then by clicking the break, the next line it will go to is this pause, because it has exited the loop. and then you can see that that's how a breakpoint works. And breakpoints are very helpful when dealing with logic and that sort of thing, as well as for troubleshooting. And then at any time, if you want to exit debugging, which is what this is called, I can either step to finish up the code like that, or I can press that little stop button that existed up there, and it'll do the same thing. So breakpoints are very useful when you're dealing with situations where for some reason the logic that you think should be executing is not, or it's behaving improperly. So let's say I did this, it's less than or equal to the second target. Say I put that in wrong, and then the while loop has finished counting the target, and then run it, and then the MATLAB count has reached 101, and which means it's done this line and then this line and exited. But I wanted it to get to 200, so I don't know why that is. I put a breakpoint here. Why is it going into this? Oh, sorry, it's still paused. Why is it going into this logic when I don't think it should be? And I'll run it, and then I see I is 101, so then I take a step and I see, okay, it's getting in here. Well, maybe that's because, oh, look at that, it's because I wrote that incorrectly. It's supposed to be greater than or equal to, not less than or equal to. So then I quit debugging and take away the breakpoint, and I've solved my problem. So there you go. Good for troubleshooting. All right, last thing we're going to do here is another while loop with some more logic in it, getting a little more complicated now. So what we're going to do is we're going to start with 200, and we're going to continuously take the square root until we reach 1 within 0.000001, and count how many square root operations we need to do in order to achieve this. So when you think about it, I can't get exactly equal to 1 by starting with any number greater than 1 and just continuously taking the square root, because it's got an asymptote at 1, as you, I'm sure, are well aware. So what I want to do is I want to calculate it within some sort of tolerance. In this case, it's like 1 times 10 to the minus 6, and I want to see how many times I need to take the square root of an arbitrary number. In this case, we're going to call it 200 in order to achieve that. So let's define a few variables. So this number is going to be 200, and that's the number that we're going to start with and continuously square root. So I'll just put in a comment. Well, it's approximately equal to 1. It's not going to be exactly equal to 1, because that's not possible. Welcome to numerical methods. I'm going to reset I to be equal to 1, and this is going to be our index counter. Then I'm going to do another thing. So we're going to, we may as well. Let's go ahead, and I was talking here about having a maximum iterations kind of check. So let's go ahead and do that in this case. So let's do max iters, or max iterations. And let's say it shouldn't take more than 50. If it does, then I'm not good at math, but it really shouldn't. So let's do that. And a comment here, maximum iterations. And that's just going to make sure that we exit our loop if we're getting a little too refined here. We don't want to get stuck in an infinite loop. And let me see here. Oh, another thing that MATLAB likes that I mentioned, I think in tutorial number 2, is that it likes it when you initialize vectors of a recording. So let's record what every number that we get is, in order to, let's make a plot of it, like a very simple plot at the end. So I'm going to create a vector. It's going to be called record, and I'm going to make it zeros, and I'm going to make it max iters rows and 1 column. So it's just going to be a column of zeros, and now that is because I want to initialize the record vector so it does not grow in the loop, because if I were to have it growing in the loop, like every time I step it up I add another entry to it, MATLAB would yell at me telling me that it's going to be a little bit slower than normal. So we'll do that. And then I'll go ahead and initialize the first record to be equal to our number. So record at 1 is going to be equal to our number. So let's see what happens if I run this. It's going to go ahead. Oh, I got to go through this whole thing up at the beginning. Sorry about that. I should have taken away the pause there. Anyway, so we'll do that. So here we go. I can call up record, and you can see it's just a bunch of zeros, but the first number should be 200. And now every time we take the square root, it's going to fill it in with more and more numbers, like that. We know that number is equal to 200. There we go. And max iters is going to just be a scalar. It's 50. So there you go. So we're going to have that. And now let's go ahead and throw in our while loop. So let's say while, and then we want to calculate this to within 1.000001. So we'll say while number is greater than 1.12345, like that. So this is going to continuously calculate this while that's happening. and then I'll give myself some lines and throw in an end down here. I will go ahead first of all and say fprintf, just so we know what's going on. MATLAB is performing square root calculation number, and then I'll put in a placeholder, %g, a new line, and that, and it's the ith, so the first, in this case, the first time through the loop, it's going to do the first square root, then the second square root, etc., etc. Leave that, and then I'll say that number is equal to square root, which is the sqrt function of number. So I'll just square root itself, and it's going to overwrite itself as a new smaller number. And then I'm going to have to do I equals I plus 1, because I'm going to have my iterative counter moving up so that I continuously have this guy updating, as well as keeping track of how many iterations I've done to get out of my logic. And the last thing I'm going to do is I'm going to do the record, and I want the ith, so in this case it's going to be the second. I want the second entry in record, because the I is going to be 2 the first time through the loop, and I'm going to call that number. So that 0, if I go over here, this second 0 here is going to be overwritten with the square root of 200, which is going to be like 14.1 or whatever the square root of 2 is times 10. So there you go. So that's going to be that. We'll put in that semicolon there. And then I'm just going to have it pause, I guess, briefly. We can always take these out just so we can see how it's going through. And yeah, that should work nicely. So that should continue until it calculates this to within 1.000001. I mean 0, that's the error up here, so really I want to get to within 1. The last thing I'm going to do is put in my logic to exit if in the case that I have an unfortunately detailed number up here, or I get stuck in an infinite loop. So the last thing I'll do is say if I is greater than max iters, so I don't want to go more than 50 times through this loop in this case, I'm going to go ahead and print out, we'll say it's an error, maximum number of iterations exceeded. So we'll go ahead and write that. Actually, we'll do iterations, and then I'll do a placeholder in brackets to say what that number actually is, and then I'll say exceeded, period. New line, exit the quote, put in max iters, because that's the number of maximum iterations that we want it to print out, semicolon, and then I'll do a break, because the break will get us out of the loop. And then I'll end to get out of the logic for the if statement, and that should be the end of that. And then the last line I'll do is just a really quick plot. I'll only plot the y data. I'll plot record. Now it's still going to have some zeros in it, because this isn't going to get all the way up to 50. So if it still does, I'm going to plot record, the first entry up until the ith entry when it got broken out of the loop. And I say I want to do red lines with circle markers. And as usual, I like having my line look a little bigger than the default, so we'll set that equal to 2. And then we'll see what happens. So here's what I'm going to do. I'm going to take away this pause so it gets through that first area a little quickly. Go ahead and run that. So it's finished the first loop, the first target. The MATLAB count has reached 200. We've reached the second target. So now we are at this pause right here, and we're going to go ahead and perform the rest of our calculations. So performing square root, there you go. So here's our graph that comes up. It's not very pretty, but what are you going to do? It said it required 23 square root calculations in order to get from 200 down to, let's check to see what number is, 1.000. Oh, well, we don't have enough significant digits over here to see what it actually is. So here's a useful thing, little tidbit. If you do format space long, it'll change the number format in MATLAB to take 8 decimal places instead of 4. So now if I pull up number again, you're going to see, or sorry, it looks like that's 12, 4, or 16. Some big number. Anyway, I think you got 16 digits in total. So you can see that we actually have 1, 2, 3, 4, 5, 6 zeros and then a 6, 3. So we are slightly less than 1 point and then 5 zeros and a 1. So it has performed its calculations appropriate. So there you go. So that has worked nicely, and then it went ahead and plotted it. Of course, once you get asymptotically close to 0, it just kind of looks like 0. We zoom in on this guy here, you can see it's, or sorry, not 0, 1. It's basically just a flat line at 1 at this point, where our data points are 1, 1, and 1. It doesn't give you that much resolution there, but I can guarantee you that. So we can also pull up record, and you can see there you go, the first 23 or so entries has been fulfilled. We had 200, this is all times 1 times 10 to the 2, so it's all times 100. And then we got down, 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 and then the rest of these are just going to be zeros because that's what we initialized them to. But remember, we only plotted up to this point, that's why it doesn't drop down to 0. Okay, so now the one thing to see if this maximum iterations thing does work, if we change this to be exactly equal to 1, we know that this logical loop will never be able to achieve that using just the square root because we can never get down to exactly 1. So if we run this now, and it counts to its first 2 targets, now what it's going to do is it's going to run through all 50 iterations, and it's going to say the maximum number of iterations is exceeded. And if I bring over the graph, it comes up. You can see that we do get down to 1, but we're not able to get down to all zeros because the machine is just not able to calculate it, not to mention the fact that the square root command is just not able to achieve that kind of accuracy, or it's not able, not accuracy, but it's not able to get down to exactly 1 by just taking the square root of something because it's just not possible. It's got an asymptote that goes out to infinity. So you would need infinity square roots in order to do it, which we obviously have only got a maximum of 50 here that we put in. So it's telling us that our maximum number of iterations is exceeded. So that just shows you that we have gone into our little logical loop here. I did get up to 51, it went too high, so we just exited the loop to make sure that we don't get stuck in a loop for too long. Anyway, that's all I wanted to talk about today. I hope that was pretty helpful with looking at different types of logic. So if-else statements and while loops and for loops are all very prominent. You're going to get a lot of practice with these kinds of things. This was just meant to be a brief introduction to what what they look like. So I hope that was helpful. Sorry again that this has gone on a little longer than I intended. But yeah, if you have any feedback, don't hesitate to send me an email. If you have a topic that you want me to cover, I think this is going to be the last of the tutorials that I'm going to look at, unless people have a certain topic that they want me to cover. So I hope that these have been helpful, and I hope you guys do great in 3EO4, and I'll see you in tutorial, and have a great day. I'll see you next time. See you.